Heat treatment of aluminium alloys. Heat treatment refers to processes enhancing strength and hardness in aluminium alloys, particularly precipitation hardenable ones. Heat-treatable alloys are distinguished from non-heat-treatable ones, which rely on cold work for strength. Commonly used heat-treatable alloys include 2000, 6000 and 7000 series wrought aluminium alloys, as well as certain casting alloys. Precipitation hardening systems, like the aluminium-copper system, form the basis for understanding heat treatment processes. Heat treatment to increase strength of aluminum alloys is a three-step process: solution heat treatment, dissolution of soluble phases, quenching, development of supersaturation, age hardening, precipitation of solute atoms either at room temperature, natural aging, or elevated temperature, artificial aging or precipitation heat treatment. The first step in heat treatment is solution heat treatment, which aims to dissolve hardening phases in the alloy. Quenching is the most critical step, where the alloy is rapidly cooled to preserve the solid solution formed. Post-quenching, age hardening occurs, either through natural aging at room temperature or with artificial aging at elevated temperatures. Natural aging allows certain alloys to develop high ratios of tensile to yield strength and great toughness. Artificial aging requires careful consideration of temperature and time to optimize specific properties, like tensile or yield strength. Alloys in T6 type tempers generally have the highest strengths practical without sacrifice of the minimum levels of other properties and characteristics. T5 temper occurs when before artificial aging, the product receives partial solution treatment or non-complete quenching. Alloys in T7 tempers are over-aged, which means that some degree of strength has been sacrificed or traded off to improve one or more other characteristics. Strength may be sacrificed to improve dimensional stability, particularly in products intended for service at elevated temperatures, or to lower residual stresses in order to reduce warpage or distortion in machining. T7 type tempers frequently are specified for cast or forged engine parts. Precipitation heat treating temperatures used to produce these tempers generally are higher than those used to produce T6 type tempers in the same alloys. Thanks for watching. Remember to like, comment, and subscribe.